today's notes are on raising powers to powers, right? So we're looking right here. This is lesson 3 in your notes. At this point, you should feel comfortable expanding powers, just using the definition of powers. I'm going to look at example 1 here, and I like to work my way from outside in when we're talking about powers. So let's go ahead and look at this 2 is going to tell us what to do first, right? So remember, that 2 is telling me everything inside my parentheses is going to get multiplied by itself 2 times. So this is like saying 2 to the 3rd power times 2 to the 3rd power. And then inside each of these parentheses, we're going to have 2 times itself 3 times. So we're trying to recognize a pattern here. So how many 2's do you see? Okay, so we could obviously have 2 to the 6th power, and we can use our calculator for this, or you can just type in to get the actual number, the final result. But keep this in the back of your mind as we're going through these problems, okay? Start looking for patterns, okay? Again, we're working outside in. This 5 is telling us we need to multiply everything inside the parentheses by itself 5 times. 2, 3, 4, 5, okay? And inside each of these parentheses, we have 3 times itself 2 times. So I have another pair of 3's, I have 3 pairs of 3's, I have 4 pairs of 3's, and I have 5 pairs of 3's, okay? So again, you can clearly say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs of 3's, right? And again, I'm just going to use my calculator. You could have also done this by hand and said 3 times itself 10 times. You'd get 59,049. Again, our goal here is trying to see some patterns. Okay. That's example 1. Example 2. We are going to start by expanding this, right? So again, everything inside the parentheses. So inside the parentheses, I have 3 times x to the 4th power times y times 3. So I'm going to do that with 3 times. And I'm not going to completely expand it. I'm going to start shortening it a little bit. So this is saying I have 3 times itself 3 times. So it'd be 3 to the 3rd power. And then we already have a power rule for when we have the same base but different powers. So when we have x to the 4th power, I have 1, 2, 3 of those. So I'm going to add all these powers. We'd have x to the 4th plus 4 plus 4. And then remember, when there is no power, there is a 1. So we have 1, 2, 3 y's. So we have 1 plus 1 plus 1. Okay, so use the calculator real quick. For 3 to the 3rd power, we get 27. 4 plus 4 is 8, plus 4 is 12. And y plus 1 plus itself 3 times is going to give us this, right? And this is going to end up being your answer, right? You should start to see a pattern here. Please start thinking about the patterns. Try and recognize some patterns here. Okay, again, example 2, now letter B, again, work outside in. So I'm just going to write, I have 2x squared y to the 4th, that's 1. I have 2x squared y to the 4th, that's 2. I'm going to run out of room. 2x squared y to the 4th times 2x squared y to the 4th times 2x squared y to the 4th. Okay, so there's my 5. I have 1, 2, 3, 4, 5. Now we have 1, 2, 3, 4, 5 2's. So that's 2 to the 5th power. I have 1, 2, 3, 4, 5 pairs of x squareds, right? So we can do 2 plus 2. We can add them all together. You get x to the 10th. Mr. Siegel needs to slow down. All right, we have 1, 2, 3. Highlight these as I'm doing them. 1, 2, 3, so you can see what I'm doing. I'm adding them all together. Here's my highlighter for this one, and then plus another 2 for this one here. Okay, so now we're going to have, can't get this all in the same lines. We have y to the 4th plus 4. We'll do this in lime green. We have 1, 2, 3, 4, 4, 5, right? I'm just adding up all of these y to the 4ths. I should have 5 of them in total, 5 fourths, okay? So 2 to the 5th power, just use your calculator for that. 2 to the 5th power is going to be 32. We have 2 plus 2 is 4, plus 2 is 6, plus 8, 10. So we have x to the 10th power. Then we have 4 plus 4 is 8, 12, 16, 20. So we have y to the 20th, right? So we started with y to the 4th to the 5th power, x squared to the 5th power, 2 to the 5th power, right? All of that to the 5th power, okay? We end up with 32 x to the 10th, y to the 20th. We started with 3 x to the 4th y, all to the 3rd power, and then we end up with 27 x to the 12th, y to the 3rd, okay? So what we're going to do now is we're going to start including some little more complicated problems. So if we go flip to the back side, example 2, we have, again, when you're raising powers to powers, work outside in, okay? So what I would recommend doing is expanding this bottom part here. Okay, so we're going to start by just copying just the negative 6, j to the negative 9th. Just copy it down for now. And this is saying I'm going to have negative 2, j to the 4th, negative 2, j to the 4th, and then I have negative 2, j to the 4th, okay? Because that's what the 3 is telling us, okay? At this point, I would recommend you start simplifying, and before you simplify, moving negative powers, okay? So I like to move this negative power right now. Okay, so we're going to have negative 6. I'm going to bring that down, so we'll have j to the 9th. We have negative 2, j to the 4th, negative 2, j to the 4th, negative 2, j to the 4th, okay? Okay, so negative 6 stays on top. All right, so looking at my problems, I have negative 2 times negative 2. That's going to be a positive 2, positive 4. Positive 4 times negative 2 is going to be negative 8. So on bottom, we're going to have negative 8. And then I'm going to have all these j's on bottom, right? So we have 1, 2, 3. We have 4 here. So we just, when we're same base, different powers, we add the powers. So I can do 4 plus 4 plus 4 plus 9, and we'll have j to the 21st downstairs. From here, we're just simplifying, right? We have a negative on top, we have a negative on bottom. We can simplify that to, they're both going to end up being positive. And we can also simplify because 2 goes into 6 and to 8. So I can divide the top by 2 and the bottom by 2. Okay, so we'll get 3 on top, 4 on bottom, and j21 stays right there, okay? All right, so that's C. We've got one more problem to do. Okay, so on top, the negative 5 t to the 5th power is staying there. On bottom, this is just saying 5t to the 4th times 5t to the 4th. No negative powers. Okay, so I'm going to simplify the bottom part. We have negative 5 on bottom, t to the 5th. On bottom, it's going to be 5 times 5 is 25. We have t to the 8th because we do 4 plus 4 is 4 plus 4 is 8. Okay, so now we just got to simplify. We have negative 5 on top, positive 25 on bottom, right? So we can divide the top and bottom by 5. And we're going to end up with just 5 on the bottom, and it's going to be, the whole problem is going to end up being negative. I also have 5 t's on top. So one way to think about this is I could have done 5 minus 8 to the negative 3. We still have 5 on bottom. We have a negative power now, so we just move it down. So we have negative 1, 5t to the third. Okay, there's your final answer for that one. Okay, so some of you should have seen the pattern at this point. Anytime we're raising a power to a power. Okay, so say we have x to the nth power, and I'm going to raise it to the nth power. Anytime we're taking a power and raising it to a power, we're going to be multiplying these together, right? So if you look back to our problems, this is m times n, right? I could have skipped a lot of these steps, like right here, for example. Notice how we have 1, 2, 3. Well, this is 1 here. 1 times 3 is there. And whenever we have -2 to the third power, it's going to end up being -8, which is what we ended up with. We could have also said, hey, j to the fourth power raised to the third power is just going to be 12, right? And that's what we ended up with down here. I just didn't write it out that way. Okay. Same thing on the first page. Let's take a look right here. We had 2 to the third power squared, right? Well, that just ended up being 3 times 2 is 6. I could have skipped all of this. This is why we're trying to get you to see the pattern, right? I have 3 to the second power raised to the fifth power, right? 2 times 5 is 10. Okay. That's the first rule. Please write that down. The next rule is anytime you have multiplication. So say I have x to the m. Whoops. Let's go back. X to the m, y to the n, and I'm going to raise all of it to the a. Right? All we're going to do is just distribute, right? So it's going to be m times a, y, n times a, right? That a is going to go to both the m and the n. Oops, just wanted to erase the arrows. Okay, cool. And then it also works over fractions, right? So say I have x to the m over y to the n, and I want to raise this all to the 8th power. This is going to turn into x m times a over y n times a. Okay, so please make sure you have those 3 rules written down and take a look at the Delta Math practice at this point.